Hi everyone, welcome back to another Noria webinar. We're excited because our friends at Asset Watch are sponsoring this one, and the topic is fantastic. Because we know with predictive maintenance, there always seems to be, debates, which technology is better. Well, here we're going to be talking about how they partner together, how they actually are used in concert. So yes, this is when vibration meets oil analysis. It's going to be great. As always with our webinars, right, this is moderated, so please use the Zoom chat feature or the Q&A feature in the Zoom window. We'll be monitoring those. We'll be answering questions as we go, and we do have a Q&A session towards the end of the webinar. But as always, I'd like to start with a little bit of introduction. So my name is Wes Cash. I'm the Vice President of Services here at Noria. We've got Kyle with us. So Kyle, why don't you give a little introduction here?
Thank you, Wes. So my name is Kyle Privet. I'm the Lubrication Program Manager at Asset Watch. I've been in the maintenance and reliability worlds for 18-ish years now.
Yeah.
About 15 of that's actually been in reliability-specific roles, with a heavy oil analysis emphasis for about the last 13 years.
Gotcha.
So happy to be here.
And obviously diving in, I mean, great company here, Asset Watch, really known for vibration.
Yes.
And obviously with your background in oil analysis, now we're able to marry these things together a little bit better.
Absolutely. Bringing multiple modalities together to get better insights on our equipment. It's a great thing.
Absolutely. So as we go through this, right, I want to kind of set the stage here a little bit, right? Predictive maintenance or predictive technologies, as you well know, we've kind of gone away from the idea that someone is going to specialize just in one thing and that's what they're going to hang their hat on. You're actually starting to see more of this done in concert, which I think is a great way to be, because at the end of the day, what are we trying to do? We're trying to catch failures before they're catastrophic. We're trying to schedule things. We're trying to obviously reduce downtime. That's the whole name of the game. But the earlier we can detect, the better we can take action, correct it, and everything else.
Absolutely. I mean, I couldn't have said it better myself there. It is all about finding those problems, getting to them before they're catastrophic. A lot of times we can change that P to F curve by catching it soon enough. We can start stretching that curve out instead of having a much shorter window to catch those things. So using these multiple technologies, bringing them together in concert it's more than the sum of its parts.
Yes. Yeah, well, absolutely. And I mean, the PF curve, I mean, a lot of people, view that as kind of an academic exercise, but it's a true way how machines fail, right?
It is.
So the earlier we detect it, the further up on the curve. We have this concept, we call it preserved RUL, or preserved remaining useful life. So if we catch it earlier, we're preserving a certain aspect of the life of that machine to where we can take some sort of corrective action. And of course, that's what we're going to dive into through the rest of this webinar, right?
Absolutely.
So let's jump into this. So if we were talking about we're marrying vibration and oil analysis together, there's of course strengths and weaknesses on both sides, right?
Absolutely.
So if we start with oil analysis, of course, Noria, I mean, we're heavy in the lubrication and oil analysis field. I mean, this is strong background
Yes.
in your side as well. We would say the strengths of oil analysis is obviously early detection of wear-related failures, but there's some caveats there, right? It's specific types of wear, but we're also proactive with oil analysis because we can check the contaminant levels, we can check the properties of the lubricant, we can make sure that everything is good to go before it even gets to the machine.
Absolutely. Yeah, it's following that oil before it's ever used. We start taking ownership of it from the time it's delivered.
Yeah.
It is a powerful tool, but it does have its downsides, like you said. There's snapshots in time, and depending on our sample frequency, those may be longer or shorter, depending on the type of equipment, the criticality of it, and even the KPIs of the site.
Yeah. And you'd already brought up the PF curve. And for those that know, I mean, most people on this webinar, I'm sure, are familiar with this. What we call the PF interval, right? It's basically the length of time between a failure starting to become a functional failure, right?
Yes.
And if that PF interval, let's say it's 2 weeks, just pick a number, but we're sampling every month or every quarter, since it is just a snapshot in time, there can be a likely failure that we have no visibility into if our sampling frequency isn't dialed up enough.
Correct. And I mean, I know I've been in those situations. I'm sure you've been in those situations too, where our samples look great.
Yeah.
And then it fails.
Then something happens.
And it's because we did have, that started failing between those sample cycles.
Yeah.
So it is unfortunately a big downside to oil analysis.
But the good thing about it is you are able to detect wear mechanisms incredibly early with oil analysis.
You absolutely
So
are.
you can see the small debris, it's finite. It can actually start to point you towards different mechanisms of failure, kind of what is going on, as well as the location of what is wearing out inside the machine.
Absolutely. Yep. And and even the precursors. I mean, look at our contamination.
Yeah.
That plays a huge role in how quickly our machines wear out. And that's something that oil analysis is great at.
Yeah, absolutely. So, whenever we think about oil analysis, big strength, early detection, we can be proactive because we're monitoring things ahead of time before a failure even starts to give it a good life. Drawbacks, well, sampling frequencies could be an issue. The sampling process.
Oh, absolutely.
Is that where you're going to go?
That's a huge, huge factor there. Who's taking the samples? How skilled are they?
Yep.
Do they know the right procedures and processes to get a good, clean, representative sample?
Or do they just take it out of the drain, or do they change the location every time?
Exactly. Your sample is more of this water bottle from the drain than actual oil.
That's exactly it. So, I mean, there's good and bad. Now, when we get into vibration analysis, right, probably where people see a big strength in vibration, especially through Asset Watch, right, where we have something sensor-based, all right? Now it's nearly real-time, if not completely real-time, depending on how it's actually structured.
Correct, yep. It's pretty close. I mean, we kind of have a basis where we're not able to, well, I'm not going to say we're not able to pull continuously. It's very frequent, though. We can adjust the sample rate of those sensors. We can shorten them up if we're watching something in real time, or lengthen it out if it's a less critical piece of equipment, or if we need to think about battery life or things of that nature. So we can go from 3 hours all the way down to 5 or 15 minutes between samples.
Sure. So
it's
we get a lot of
very nearly real time. Definitely a lot more frequent than oil analysis.
Sure. And there is sensor-based oil analysis, but I mean, that's a whole other ballgame at that point.
It is. Yep.
Now, whenever we think about vibration, and my counter to this is, if we are seeing something in vibration, in a lot of cases, there's some sort of, we can call it damage or surface defect that could be going on.
Already an anomaly of some sort.
There you go. So generally, most people will say, well, vibration shows up further down that PF curve than what we'd be able to detect with oil analysis. But with sampling frequency, you're able to detect it
Absolutely.
early.
And I mean, conversely, there's also some things where vibration will pick up where oil analysis won't necessarily pick it up.
Yeah, I think misalignment.
Misalignment, soft foot conditions,
Imbalance,
things of that nature. I mean, yes, some of those will go into wear eventually.
You would detect it eventually.
But that is a case where it flips around on us, where
vibration shows it very early.
Exactly. So
and you can take corrective action at that point.
Absolutely.
Now, obviously, with vibration, some people get deep into the weeds with it, much like you get with oil analysis, right?
Oh,
This is where people start to get very specialized. But from your aspect, and of course, being with Asset Watch, you're kind of on both sides of the fence here. Customers that do collaborate the data or corroborate the data with themselves, right? Vibration and oil analysis. Do you see them catching more faults? Do you see them avoiding faults because they are focusing on lubrication? What do you typically see?
So that is a great question, and a lot of it comes down to buy-in.
Yeah.
That's a big part of it. If the customer understands what's going on, if we're communicating effectively with them, they have the skilled people in place to make the right decisions, to get the right assets, resources, human resources allocated, the right parts allocated, we see tremendous growth in those facilities. I mean, we see, we start in, we get our initial data sets, we see a lot of issues. They start getting those corrected, and we start seeing fewer and fewer and fewer issues over time. Their plants become more reliable by combining those things together and acting on those recommendations, acting on the knowledge and the skill of our vibration technicians, our vibration CMEs as we call them, as well as our lubrication CMEs. So, there's a huge collaborative effort at Asset Watch between the lubrication side and the vibration side. We have that skill from both sides. It's really a big team effort, and that's where we want to work with those customers, with those sites, be an extension of their maintenance programs to make them more efficient.
And I love what you hammered on there, because I think some people will miss that idea. With a predictive maintenance program, it's not always about just catching faults, right? Ideally, we see fewer and fewer faults
Ideally.
as the program matures and as we truly get into that reliable state. And this is where proactive maintenance comes in and everything else. So to hear from you, hey, we see these people that buy in and actually the number of faults are failing or are falling. I mean, that's fantastic, right?
It really is. It really is. And it shows the value of it, because that's freeing up their people and their resources to do other things. They're able to take on new tasks, and they're able to level up their maintenance program. So it's a fantastic thing to see.
Yeah. So let's talk about, all right, actually getting into the weeds a little bit of correlating the data together, right?
Yes.
Of actually looking at it, because unfortunately I've been into facilities, you probably have as well, where these are two disparate programs.
Yes.
It may even be different people involved, that they don't work together or they don't cross paths. So if we're talking about maybe starting out of cross-verifying the data, where do you see people start with that?
So where we ideally we're going to be looking at criticality of assets first.
Sure.
And
there you go.
That's standard practice there. We want to make sure that we're going after, I don't necessarily want to say the lowest hanging fruit, because sometimes it's not, but the highest value per dollar assets there are. We want to make sure that we're keeping that facility working and running smoothly. Bringing that data back into it, we want to identify those issues. A lot of times we are going to find imbalance issues very early on.
Sure.
We're going to find those soft foot, those mounting issues, those misalignment issues really early on.
And it is possible, right, that the one technology, vibration says everything's perfectly fine. Oil analysis is screaming something saying, hey, it's loaded with particles or something like
Absolutely.
that. So you can't rely on just the one green check mark of saying it's fine. You do need to look at these different data sources.
Absolutely. I mean, there's a tool for every problem.
Yes.
And that tool may not be the same for every application.
Yes.
I mean, that common saying is a screwdriver isn't a chisel, even though we try to make it that way, right?
That's right.
So it's one of those where, yeah, absolutely, vibration may look great, but we're loaded with particles in that sample. We are going to be causing accelerated
Someone
wear.
put in the wrong oil.
Absolutely.
I mean, that happens.
All the time.
So we're looking at these different things, and if we're talking about starting out, ideally, right, lubricant analysis is kind of cradle to grave, as you mentioned, right?
Yes.
So when the lubricant first shows up, right, we do our analysis, make sure that it's good to go, right, and then as it goes into the machine, we're taking our routine samples, but now we've got vibration data to actually help us, see the better picture of what's actually going on. And as we start to push these two together, this is where there's a difference between detection and diagnosis, right? So either technology by itself could either detect or diagnose. But in some cases, you may detect it with one technology, diagnose it with the other. Is that correct?
Absolutely. Yeah. I mean, we may have an issue where we're starting to see some chromium in the oil. Only 1 or 2 ppm, not a lot. Hey, we're watching it. We can't make a for sure diagnosis on it yet, but then we have those vibration sensors on every bearing on a gearbox, and we see pretty consistent data on 3 bearings, and the 4th bearing, we're starting to see some bearing noise.
There you go.
So, hey, we're starting to see some traces of bearing. Now we know which bearing it's coming from.
Yes.
So that maintenance team, instead of having to replace all 4 bearings because they don't know which one's bad, they can go right to that trouble bearing and see what's going on with it. Is it, and is it a drive bearing? Is it a non-drive bearing? Maybe it is a coupling issue that has started something, or an alignment issue there.
Yeah.
So it can definitely cause problems, but that helps us pinpoint where that issue is coming from, making the repair process that much more efficient.
And I've seen this before, right, where you start to see traces of something. You get signals, right, something's going on. All right, we open the machine up, and everything, quote unquote, looks fine inside. But we need to understand that the failures that we're detecting, if we're doing it right, may not always be visible to the naked eye. It may require some further diving into bearing number 4, like you talked about, or something of that nature.
Absolutely, it is. it's really hard to do a visual inspection on a bearing.
Yes, it
You
is.
know, without
When
removing it and
inside a
cutting it apart.
gearbox and everything.
Exactly,
Yep.
yeah. Without doing some sort of post-mortem of it after it's been removed, and even then, you may need a microscope to see what's going on with it.
Yes.
So, yeah, ideally we want to get well ahead of those failures. And even if it's not something we're going to repair this week or next week, we can get ahead of it enough that maybe this steel mill will be able to put it on their list for the next outage in 3 months.
Yeah. Absolutely. Then we have the right people, we have the right spare parts, right?
Absolutely.
Now we don't have the expedited shipping fees or
Yep.
something to get things there.
Absolutely. We're going to have the parts and the people there ready to make it go as fast and as efficient and safely as possible. Because that's another thing to factor into this. Anytime we have that reactive down, immediately it becomes less safe than if it's a planned job ahead of time.
Oh, absolutely. There's all sorts of OSHA and MSHA studies
Oh, yes.
that basically showcase if a job is unplanned or in a reactive state. The last one I saw was hand injuries.
Yes.
Was such a dramatic increase
Oh,
with
yeah.
reactive maintenance plans because, yeah, I mean, the goal is get it back up and going.
Exactly. It makes sense. These technicians are under a lot of stress, a lot of pressure to get this equipment back up and in production as fast as possible. And, hey, things happen when you start swinging hammers.
Yes.
And, the more care, the more time those technicians can really focus on having the right tooling available.
Yeah, absolutely.
Yeah.
And different mechanisms, right? So we've talked a lot about machine failure mechanisms, right? So a bearing going bad, gearing going bad, something like that. Vibration, fantastic. We can see the wear metals, right? The deal with oil analysis, right, is it's got to be in the bottle for us to test it,
does.
right? If it's not in the bottle,
We don't see it,
labs,
yeah.
the lab's not going to see it. But I also know that you have more real world case studies
Yes.
where we've seen some of this actually work.
Absolutely.
Right. So let's dive into maybe one sticks out or something like that.
Yeah, we can. I brought two with me to talk about, but we'll dive into the first one. It's a steel mill, so it is on a recoiler gearbox.
Okay.
So for those unfamiliar, coils they get uncoiled, whatever process they go through,
Thin, cut, something.
Yep,
Who knows,
exactly,
right?
and then they get recoiled back up. So this recoiler gearbox, we had been seeing some issues in the vibration data. We were seeing basically gear mesh frequencies and side banding. So in the time waveform and in the data that we're seeing there's these peaks that are very indicative of that gearing.
Okay.
So we started working with this customer, getting into oil analysis. Well, what we saw was, there was some wear going on. We were seeing some iron and stuff. It was like,
So
hey,
we've taken a sample now.
Yep.
Vibration has alerted us something's going on.
Yep.
Let's dig a little deeper. We're taking samples.
Yep. So we're seeing iron. We're seeing high wear metal or high particle counts. So hey, let's get this oil cleaned up. Let's get some filter carts on it. Let's get it cleaned up and see where it goes. A little while later, they got it cleaned up a little bit. Wear's dropped down a little bit, but not as much as we were really expecting. It's like, okay, how's our vibration look? Okay, we're still seeing the same thing. We're still seeing the gear mesh frequencies. We're still seeing the side banding. Something else is going on here. Oil gets changed as a next step. And same thing, we're continuing to see the same thing on the vibration side. We're continuing to see higher than expected wear metals.
So the first thought was, all right, we got all these particles.
Yep.
Particles lead to wear, right?
Absolutely.
I still find it fascinating that dirt is harder than most of the steel components,
it's
right?
wild.
But dirt gets in there, it causes metal shavings. All right, these metal shavings are now floating through there. Something's happening between the gear teeth,
Yep.
causing it to rattle and make noise.
Yep.
All right, so let's clean the oil up. Let's try to do that.
Yep.
All right, we cleaned it up. We're not seeing a marked improvement by any means. Let's get new oil in there, so maybe it's even cleaner at that point. Maybe we've been able to filter it, or we've got a better additive package. It's more refreshed.
Yes.
But we're still seeing issues.
Yep, continue to see issues. So, a little bit of head scratching, a little bit of brainstorming. We're going, are we even using the right oil in this? Mm-hmm. Start talking with the customer. Hey, can you get us a picture of the data tag from this gearbox? Well, there is no data tag, which obviously is very common to see on a lot of older gearboxes.
I was going to say, some of
things.
these plants have been in operation for decades,
Oh, yeah.
pushing a century in some
Yeah,
cases.
60, 70-year-old gearboxes.
Absolutely.
Turns out this one was actually custom made by their engineering group.
Okay.
So that's why it never had a data tag on it.
Yeah.
It was something designed in-house, manufactured at another one of their facilities and brought in. I was like, okay, well, we don't even know what the OEM specification, which, isn't always the word of God on everything, but it's a
Well,
good starting
and
point.
depending on the environment that you're operating in,
Absolutely.
the OEM may not know, like,
Correct.
the environment. So
Yeah, absolutely. So, we start talking to them. We're like, hey, we really want to know if this is even the correct viscosity oil because it had a 220 in it.
okay,
And,
which
it's a pretty common gear oil.
incredibly common. I was going to
Yeah.
say most people, if they were to go, buy a gear oil, 9 times out of 10, it's probably going to be a 220.
Yeah.
Yeah.
So, we start talking with them. We're like, we can, with the right information, we need to know what gearing is in there. We can start looking at doing a pitch line velocity and start figuring out if we're even in the right range for viscosity. Well, working with them, their engineering group decided to take that on.
Okay.
And, they're like, hey, actually, yeah, come to find out, we should be using a 320, not a 220.
There you go.
So,
A thicker oil at that point,
Yep.
obviously bigger lubricating film.
yes.
Now, was that the smoking gun? Did you see,
Yeah.
marked improvement after that?
So we did. So they got the oil ordered, they got the oil changed, and keeping it clean as well, another important aspect.
Sure.
But we saw the wear drop off dramatically.
Yeah.
And it was just a beautiful textbook case of we had the wrong viscosity to start with. That was causing a lot of issues. I mean, recoiler gearbox, highly loaded application.
Yeah.
So, this is one of those where, had it just been oil, we'd have been like, hey, we're still seeing a lot of wear. What's going on with this?
Yeah.
If it was just vibration.
I was going to say it's longer time period at that point.
Absolutely, yeah. With vibration, it would have been, more or less the same. We see an issue, we kind of know what's going on with it, but is it a failure-related thing or is it something else going on? So marrying those two technologies together,
Yeah.
we're able to see, hey, this is probably an issue with our viscosity. It's too thin. That too thin of oil is allowing that gearing to really kind of come into contact and change what we're seeing on the vibration data.
Well, I think what's great about that one, right, is if you were just doing oil analysis at that point, there would be however long your sampling frequency is to actually see if it's getting better, even if you change to the 320. By having vibration, you can start to see it more real time, like, did this make an improvement? So, I mean, it's a very good confirmation that it was right.
It was, and that was the thing. After we got that oil change, we get a little bit of runtime on it, of course, and we see that gear mesh go away.
Yeah.
It was like, okay, we are definitely on the right track.
Yes.
Now the next time we pull the oil, we're going to get that final confirmation that this was, the source of the problem, and now it's resolved.
Yeah, I think that's fantastic because vibration by itself, you would have no idea what the viscosity of the fluid was inside.
Nope.
You would just assume, well, it's got oil in it, right?
Yeah.
I think that's a good one. And yeah, taking it that step further because, so many times people will be like, well, my oil analysis report shows that the viscosity is still in spec. It's still good. Well, it is for that fluid, but that doesn't always mean that fluid is the match for the machine.
Correct.
Yeah.
Yeah.
So obviously, the recoiler gearbox, love that. More examples?
Yep. So I actually have another gearbox example.
Yeah.
So this is
And we're not just picking on gearing at this
No,
point.
we're not
It's
just picking on gearing.
It just so happens, right?
It's one of those. It's a natural place to marry oil analysis and vibration.
Because there's a lot of componentry inside that gearbox.
There's a lot of componentry, and it's easier to deploy those sensors. We're able to get those sensors in all different locations at all the bearings and key locations, and it just makes sense on gearboxes to have both. Hydraulic systems, you can monitor the motor, you can monitor the pump, but that's
some things get a little more difficult after
exactly.
that. Yep.
So this gearbox, this one is at a coal handling facility. So it's on a shaker deck where they clean the coal. And the gearboxes in this application are not a standard orientation.
Yeah.
So they're kind of sitting at a really awkward angle.
Gotcha.
And so it just adds to a little bit of challenge.
Absolutely.
Changes things a little bit. Not exactly the way the OEM designed that gearbox
The
to run.
loads are going to be a little different in
Yep.
different spots. Yep.
Yep. So this is another one where early on we only had vibration on it, and we didn't have oil analysis. So our vibration CME was seeing some bearing noise going on, and he was concerned about it. Was talking with the customer, and we finally got in to be able to do some oil analysis there. And so I was actually able to go pull this sample myself,
Okay.
which is always fun. I love getting out on site still.
Yeah.
And we get the data back, and immediately it's just completely loaded. There's so much wear metal, so many particles, but we're also seeing that chromium.
Yeah.
And, we're seeing it at
So you got a telltale, right?
we got that telltale, and we're seeing it at a pretty high level.
We're going up. Yep.
Yeah, even with only one sample, we don't have that trend, but typically we're not going to see more than 0, 1 on most, pretty good samples there.
Yeah, and every machine's going to have its own trend.
Absolutely.
Sure.
But historically in most gearbox applications, we're not going to see a ton of chromium. So seeing it at that level was already concerning. So, start working with them, and, they changed the oil, they let it run a little bit, and whenever they went to go change the oil again, they noticed quite a bit of glitter.
So now they're visualizing
So
what's in the sample at that point.
It's pretty far along on the P to F curve, unfortunately.
Yeah.
It would have been awesome if we could have been in there, 6 months to a year earlier,
Yes.
and seen that progression and been able to get more ahead of it. So, unfortunately, they did, have to replace that gearbox, but they were able to replace it at their schedule.
Understanding what's going on.
Exactly.
Plan it. Do I have enough, runway of this machine to last to some scheduled date?
Yeah, we have an outage coming up in a month. We have this gearbox, close-ish by, so we can get it ordered, get it in, and get it changed out on this next outage. So once again, they were able to plan that work. It wasn't an unexpected failure that interfered with their production. So you take out that screen, you take out that shaker deck, it takes out a good portion of their throughput.
Production. Yeah, absolutely.
So, even though they have, a couple different shaker decks, you can have your production with unexpected failure. Well, now you're trying to work with technicians in that coal facility. Is it safe for them to work next to that other shaker deck?
That's right.
So, while unfortunately the gearbox still had to be replaced, they were able to do it scheduled.
Yeah.
And that is the key on that one.
Yeah.
But, we were able to see that progression, and the vibration side, we did see that bearing noise. It would have been awesome had we had that oil analysis data ahead of time.
Going back, yeah.
Exactly. So
Because the trend analysis is powerful.
absolutely. One sample tells you something.
Yes.
But it's that trend, that going from what is normal to what is abnormal, that inflection point to where you go abnormal. That's the key.
So obviously the technologies are fantastic, but we need to address the soft skills of things, right? Because this program is going to involve staff. So we probably need to talk about how to begin, marrying these two programs together, the two technologies together. And I think it starts with, all right, understanding your facility. Who is responsible for oil analysis or the lubrication program? Who's responsible for any other predictive technologies? And we need to make sure that those people at least have some sort of working relationship. That's kind of like straight out of the box type stuff.
Absolutely, absolutely. So, with Asset Watch, you have dedicated people to your facility. So your lubrication CME is going to stay constant.
CME, just so everyone knows,
is a condition monitoring engineer. They are our analysts.
Yep.
So your lubrication CME, your vibration CME, they are dedicated to your site, to your facility. They get very familiar with your equipment.
Well, obviously, the people have to talk, right? They're
Absolutely.
masters of their domain, but they need to understand,
Yes.
some idea between the two.
Yep. So you build that rapport with those people on site. You build the rapport with that maintenance manager, with that facility manager, even with the technicians. So there's a lot of times our customers will have the technicians sit in on the data reviews and talk to us directly, as well as in the platform, they're able to communicate back and forth. So communication is key for making these programs successful.
Yeah. Communication and access to the data.
Absolutely.
Because a lot of plants, all right, they send something off to a lab. So the lab may have its own dashboard or something they log into. Then they've got their own, software over here that the vibration stuff, exists in.
Yep.
So sometimes it's hard to actually pull the data together.
Yes, yeah, having that data siloed in multiple platforms just makes it that much harder to make it work together.
Yes.
So being able to go onto one platform, one login that you have to remember. How many times are we being asked to reset our passwords? No, you can't use the same password from 6 times ago, you know. So having that one platform where you can come in, you can see all your vibration data, you can see every sensor of that asset, you can see your oil analysis data for that asset all in one place. You can make those correlations, you can make those keys. If you have those people with vibration knowledge on your staff, they can go in, they can manipulate the data, they can see, you know, into the waveforms, they can zoom in on it, they can identify issues as well, or, you know, be able to correlate and corroborate with our analysts. Likewise on the oil side, able to go in, you're able to pull your full report and see your full report anytime you want. So no more having to keep a folder in your email that things are going to automatically because you're getting 20 reports a day. You know, it's right there when you need it.
And probably when we start, you'd already talked about, you know, a pilot project or something. Most people probably start with critical assets, but
Absolutely.
at least start somewhere. Starting small and growing that program is not a bad way to go.
It is not, and it's flexible in that way too. You know, we can come in, we can install on a handful of assets to give you a feel for what it is, give you like a 30-day trial, and you know, hey, this is what we're going to see, this is what we're doing. Here's, you know, your analysts. You're able to talk with them, really work together towards a solution and common goals on things. And you know, at the end of that, if you go, hey, this is great, I love it, I would like to expand this out, no problem. We'll get somebody out there to expand out. We have our technicians that can come on site and put all the sensors where they need to go. So it's not even something that the site has to handle. We have our own technicians, our ARTs, our asset reliability technicians. They'll bring all the sensors, they'll bring all the hubs and hotspots, they'll get them installed around your facility. So it's a turnkey solution. And you know, that really saves a lot of time because, I mean, let's face it, everybody is short on labor right now.
Of course.
Skilled labor is hard to find. So having somebody else be able to come in, you're not taking away from your maintenance personnel to even get the system set up.
Yeah.
So
I think it's a great solution, and you know, out of respect for the people in the webinar, I know we've got a lot of questions going in. So I think at this point we'll probably move to a little bit of Q&A and kind of go through what people have been asking.
Sounds good.
All right, so we've had quite a few questions come in, so we're gonna go through some here. So first question here. For oil analysis, is it necessary to identify the type of internal metal components of the machine where the oil mostly resides?
You know, from an analyst perspective, it's great to have that data. Yeah. It helps identify those issues.
The word necessary, probably not necessary, but you want to talk about like making it a lot easier?
Absolutely, yeah. I mean, there's going to be some common things that we see in, you know, different things. We're going to see, you know, certain metals in gearboxes kind of across the industry. You know, spur gearboxes are going to have certain things, whereas worm drive gearboxes are going to have something else. Where we're probably going to see exactly, like we're going to see more copper, probably some lead, you know, from that bronze alloy for the bull gear. So, you know, there's some things that we just kind of learn over time and we know. But at the same time, if you do have the ability to get that exact metallurgy, it is incredibly beneficial. I did have the opportunity to help build out a metallurgical library at a previous location using an XRF.
The gun go out there and actually shoot the materials. Yeah.
And it was amazing. I mean, we could identify where was coming from. You know, we would see a certain level of nickel in the oil analysis or the centrifuge analysis, and then, you know, I could say, hey, we're seeing this from a rocker arm or a rocker bridge. So we need to, next time this truck is in on, you know, a PM, we need to start pulling valve covers and checking out the overhead. Versus if we're seeing this, you know, copper in this ratio with another element, this is probably going to be a centrifuge bushing or a thrust bearing.
There you go.
And, you know, start digging back through, you know, work order data then as well, and see if we did something recently that may have caused that wear. So is it necessary? No. Is it beneficial? Absolutely.
Yeah, tremendously, right?
Yes.
And you had mentioned chromium several times as we were talking about, you know, some of your case studies, right? If someone just saw chromium on a sheet, right? I mean, it's just numbers on a page, and they would probably get to the same ideal or you know, realization at some point. But knowing exactly, all right, what parts have chromium in this facility or in this gearbox or something helps out.
And not just that, but also the ratios.
That's it, because with the XRF, like you were talking about, all right, this component is this percentage iron, this percentage whatever, right? I mean, you can go
Absolutely.
a lot more detailed at that point.
Yeah. There is a lot of legwork to build that library out. There's, traveling around, or if you have the ability on site, take these components apart and put the time in to be able to build out that library. So that is one downside to it. But it also allows that person to get way more intimately familiar with those assets and those components.
Yeah, there's kind of a peripheral benefit with that as well.
There is.
Yeah. All right, next question here then. How do you identify proper sampling intervals?
So this is going to be a lot of that criticality.
Sure.
It's one of those, is it something that is going to take our facility offline for an extended period of time, or is it a secondary or tertiary asset? If it's a critical asset, I'm always going to err on the side of let's get more frequent samples. If we can't get more frequent samples, let's say we're limited for whatever reason to quarterly samples, then we also need to look at what we can do on site in between those sample intervals.
There you go.
Can we do a crackle test on site, which pretty simple to get a hot plate and do a crackle test on site. Can we do mag plug inspections? Can we do, do we have a 3D sight glass or like a pod that we can view the clarity of the oil, see the condition of it that way? So high criticality, definitely err for more frequent. Or if we have something that's starting to indicate that it may be going into a failure state,
There you go.
decrease that sample interval. So, we may even go half or even shorter on the interval.
And see, I think that's an important thing, because so many people get caught up with, all right, I'm going to do my monthly, my quarterly, my semi-annually. You don't have to set it static. I mean,
You don't,
You can
no.
chase your targets.
You can.
If you're seeing an increase in something, then take more samples, sample more frequently at that point. I mean, there's no hard and fast rule of saying it has to be done
There is
every
not.
X, Y, and Z. Now, some OEMs may, have recommendations.
Absolutely.
So be it. But I agree, criticality is one aspect of it. We also look at, all right, fluid volume.
Yes,
There's an aspect of that. Accessibility.
Yes.
How accessible is the machine or inaccessible is the machine? Some of that's going to go into it. But it's not the same issue, right? I mean, whenever we think about vibration versus oil analysis, it's going to be frequency is frequency. It's just if we have a sensor that we can put on something, the frequency is a little bit more controlled. You have
Absolutely.
that ability. Here we physically have to take the fluid from them.
Yes.
So most often we see those oil analysis frequencies are much further out than vibration.
Yeah, and and that's a great point. Those don't have to be static. I've had those questions before. Hey, we're having an outage this week. I know we're a week or two early on our oil sample interval. That's fine.
Yeah, do it.
That's fine. That's great. We can normalize that data.
Yes.
We can trend it by day or by hour, whatever at time metric.
100 hours of runtime, whatever
Exactly.
it may be. Right?
Yeah. I mean, that fixed plant we usually do days. Mobile equipment it'll usually be more hour based, but we can normalize that data. It doesn't matter the time period. We can do it early, or if it's one of those, hey, we're doing an outage next week where we can finally get to this. I know we're already a week late. Is that okay? Yeah, it's maybe not ideal, but hey, we can still work with that. It doesn't have to be every 30 days or every 90 days.
Yeah.
It can be 25 or 35 days or 81 days or 100 days. Like we can have some variance there. That's not a big issue.
Yeah, there's some flex there. So obviously hammered that one really well. All right, if you are seeing ferrous wear debris, what's the best way to corroborate that with vibration?
So we talked earlier about seeing the gear mesh frequencies
Yes.
and the side bands there. So that's going to be one of those areas where we can really start looking at it, as well as seeing that bearing noise if it's a bearing issue. So whether it's gearing or bearing, we'll see different things in the vibration data, but we can compare that or bring it back. Once again, we'll go back to chromium like we were talking about. We see that bearing noise, and now we can see that chromium coming from that anti-friction roller bearing.
Yes.
So that's how we're going to be able to, bring those things together and marry them together.
Yeah. And as we mentioned, detection versus diagnosis. All right, which technology detected something first? I'm judging by the question if they said ferrous debris. So oil analysis detected something first. Now we're going to go to vibration, and it may require taking additional measurements or additional readings from places that we weren't in the past, or maybe even looking back upon historical trends to see if we see anything in the
Absolutely.
waveform or anything
Yeah,
else.
we may have a 6-month or 9-month trend that we're looking at that day by day we're not really seeing much change in the vibration data. But over the course of 6 months, 9 months, we do see that subtle uptick.
There you go.
It may not be at a threshold alert yet,
There you go. Yeah.
but we are starting to see that subtle uptick that we can correlate back to that increase in ferrous debris.
Yeah. And I think obviously detecting something early, that's the whole goal. If we see it, and I don't care if it's ferrous debris or chromium or anything else, right? You see some, it could be particles for that matter.
Absolutely.
Your particle count going up. And every one of them, depending on what it is, if it's a wear debris related thing, yes, vibration is absolutely. If it's particle induced, that's pointing towards seals, breathers, something else. So, everything's going to have a little bit of nuance based on what the data is showing.
Absolutely.
All right, so last question here. What specific tests are most important to perform, and how do you set parameters? And I'm assuming since specific tests, we're probably talking more on the oil analysis side on this one.
That sounds accurate. Yeah. So, of course, we're always going to want to have viscosity.
Sure.
It's the most important aspect of the oil. Got to have viscosity. We're also going to have our cleanliness, so our particle counts, our ISO codes. That's, on engines, you're not necessarily going to get that, especially diesel engines. Oil's too dark to particle count most of the time.
You can do pore blockage, get you a particle count, but most people will bypass it. Yep.
But all other powertrain oils or hydraulic oils, gear oils, turbine oils, particle count. We want to keep an eye on how clean we're keeping that oil.
Yes.
As well, we're going to want our elementals. We want our wear debris. We want our contaminants. We want our additive package. It's all great stuff to monitor. Those are going to be your basic ones. So now we may want to throw in some more stuff depending on, once again, criticality. That word again.
Or the type of equipment.
Or the type of asset. So we may want to throw in moisture, whether it be crackle for maybe, lesser severe things.
Kind of a go, no go.
Yeah, exactly. Yeah. Or if it's something more critical, or if it's one where we have a liquid cooler on it, a water to oil cooler, might recommend doing Carl Fisher on those. So that way we can start catching those issues early on if we start seeing a cooler leak. The other ones, we want acid number on gearboxes especially, and turbine oils, things of that nature. We want to keep an eye on the condition of that. Is the oxidation starting to set in?
There you go.
The engine side of that, conversely, we'll want TBN on the engine side of that.
Yep.
So a little differences there. Another one that I really like working with is PQ index. And
particle quantifier, so it's looking more wear related.
Yep, which there's a sort of a spin on that more recently called, the device is called FerroQ from Poseidon Systems, I believe it is. And it's sort of replaced PQ index at some labs, but same type of thing. It's more, quantitative than qualitative. So seeing that, comparing that reading to what we're seeing on our elementals to kind of get a range of, are we seeing smaller wear debris or larger wear debris?
There you go.
So
obviously the bigger the particles, the bigger the wear particles, the more advanced the wear mechanism is.
Absolutely. And things fail big. They don't fail small.
That's it.
Yep.
And the only thing that I'd probably add to your answer, I agree completely, right? There's a lot of nuance to it's a simple question, but a lot of nuance to answer.
Yes.
We break oil analysis into three main categories: fluid health, contamination, and machine health, or what we'd call wear debris.
Yep.
As long as we can answer the questions in those three areas, we're doing good.
Yes.
That may require a lot of tests. For some machines, it may require very few. But we need information in those three categories.
Yes.
All right. So, Kyle, definitely appreciate you joining us. For everyone on the webinar, we appreciate it. Just a couple things to point out here. You can get in touch with Asset Watch. You can get in touch with Kyle. There'll be some information coming in the screen as well as in the chat. For those of you that asked a question, put a question in that we didn't get to answer here while on air, someone will be following up with you. So just, mind your inbox and everything else. They'll be reaching out. Kyle, if someone wants to reach out to you, how do they get a hold of you?
Yep, so you can reach me at kprivet@assetwatch.com. It's usually one of the easiest ways to get a hold of me, or from anybody at Asset Watch. You can just ask for the oil guy, and they'll probably point you towards my direction. And that's a great way. I'm also on LinkedIn if you want to look me up there. So, yeah. Wes, thank you.
Oh, absolutely.
For the time here. Noria, thank you for that as well. So, been great being here.
Yeah, it's been a great webinar for everyone attending. Thank you so much for that. We once again want to thank our friends at Asset Watch for sponsoring this webinar. And we look forward to seeing you guys again in the next webinar series here at Noria.